morning, we are trash.py. My name is Marcella. I am the design and manufacturing lead.
I am Shaivi, and I am the project manager and UX lead.
And I'm Ethan, our machine learning and computer vision lead.
Did you know that 91% of plastic does not get recycled and just sits in landfills annually? When we learned about this awful statistic, we had to figure out how this issue applies to us and what we can do to help. We first sought out some people on campus who we believed could provide us resources and guidance to better understand the problem. From these stakeholder conversations we had with the Office of Campus Sustainability, professors, and sustainability-focused project teams, we were able to develop a broader perspective of the issues on campus, which can be distilled into 4 pain points. The first, recycling at UM is contaminated. Second, there are many recyclables that could be salvaged. Third, people can't decide where to throw their waste. And fourth, sometimes the whole system just breaks down. So we did some research. From data we have obtained from the Office of Campus Sustainability, we have calculated that 40% of recycling on campus is contaminated.
That is only half of our stakeholders. The other half is the users, the students and janitorial staff. We surveyed 59 students and we learned that only 10% of students feel strongly confident that they can dispose of their waste in the correct receptacles. Furthermore, 62% of students say that they will use the other bin even if it is the wrong bin, if the correct bin is overfilled. And lastly, 60% of students said that they would be happy if they were not expected to make any decisions while disposing of their waste. And if that didn't convince you that the university bins are bad, just look around. Shavy took this picture just this week at the Union. This is a problem.
And this is our solution, trash.py, a system ensuring proper waste sorting and eliminating user decisions. Our solution has an open latch deposit system that intakes the item and deposits it to the staging area. In case 1, the system concludes that the item is recyclable and the right latch swings open to deposit the item in the recycling bin. In case 2, the item is trash and the left latch swings open, depositing it in the trash bin. The solution is also fitted to the existing Michigan bins in order to allow for easier integration and use of items that the university already has available. But how does the sorting system work?
Our computer vision system begins by first taking a picture of the waste item that has been deposited. It then uploads that image data to the cloud, where it is received by our AI deep learning model, which classifies the item using a convolutional neural network. The decision data is then sent back to the bin, which can then process the item into the correct receptacle. To test our theories, we built a lo-fi prototype of the staging area and camera system using the c-sed lab. We've also developed a standalone web applet that works with our prototype to help visualize the system working and validate that our model is viable. As you can see, when the classify button is pressed, the system takes an image of the item held in our mock staging area, classifies it as either trash or recycling, and returns the data back to the browser to be displayed. Our current model is trained using the TrashNet dataset, which aims to solve a very similar problem to ours, and therefore the model trained on this data generalizes well to our example. In the future, we'll be making our own dataset using actual field data from the machines, which will allow us to be even more accurate.
Some other features in our design come from conversations with the janitorial staff. We don't want to make their job any harder or make large changes. Therefore, we added a sliding rack to give them easy access to changing the bags on the bins. And with using the bins that are already in use, they already have access to the bags that fit into these bins. As well, small LED lights on the corner of the bin help signify the status of the bin. Green, meaning that everything is working properly. Orange indicates that the respective side is full, and red indicates that the machine is not working and needs some sort of maintenance. And in order to sense that the bins are full, the slide-out rack has a weight sensor underneath that registers when these bins are full.
This would then notify the janitorial staff through the trash.py app. This is the basic prototype of how the application would look like. For each building staff handling the waste, one could choose the required campus and building to reach their own setup. Each building could have views showing the real-time status of all bins a staff member is responsible for, along with the statistics comparing recyclable versus general waste in the bins. These are some basic features, and we plan to add some more as the system evolves. Our key sustainability drivers for trash.py are reducing recyclables, improving users' experience, and reducing the MRF strain. Our two key partners as we continue to develop trash.py are the Office of Campus Sustainability and janitorial staff. Their data and feedback will prove crucial to creating a quality product.
The current market right now features the currently used Michigan bins as well as 2 other smart solutions, but trash.py is the only solution that meets our criteria of reduced contamination, reduced decisions, a small physical footprint, and easy adoption for the University of Michigan.
As we move forward with this project, our future goals include launching the first trash.py bin on campus through c-sed lab, adding compost in the sorting scenario, and educating audience about different types of waste. That is it from our side. Thank you for listening. And now we are open for questions.
Good job, you guys. Wonderful. If you want to stop sharing your screen, then you can get a sense of the judges and as they're asking you questions, that would be great.
All right.
Thanks so much. That was a really wonderful presentation. It looks really great. So I couldn't help thinking on the way through of a number of kind of failure points. Some of these are kind of informed by my own use of trash cans at the University of Michigan. So sometimes I'm doing a student event and I've got a pizza box and I need to be able to access the full bin to get the box in there, right? It seems like your solution is going to make that harder for me. So there's that. There's the kind of messiness of trash and kind of gumming up your sensors. And then, yeah, even just weight as a kind of measure of trash doesn't always hit volume. So I'm just wondering if you've thought through any of these problems. It feels like a great solution, and boy, oh boy, do I want to be responsible for throwing less plastic in a landfill. So I'm really behind you, but yeah.
Yeah, to your first point, one of the main things about our solution is that it does have that latch bin is a specific size in order to reduce the amount of things that are being thrown in at once. Because one of the main things is asking people to throw things one at a time in order for our system to be able to register them. We thought this was a good trade-off in order to not have to make decisions, because our system, we are having it run fast. So as soon as they throw one thing away, those bigger things like boxes and things like that are an issue that we have thought about. But at first we're looking to kind of implement this in like places where big events like that don't really happen, and maybe then having somewhere else like some other normal trash can or some other place to put these receptacles for like boxes and different things like that. But that's definitely stuff that we have talked about. And with the like gumming up the sensors and things, what we kind of have everything that's electronic. We had like a whole shelf that will be separate from any trash that's like thrown in order so it only really be the camera that is like exposed to any sort of like liquids or things like that. That's at least what we thought about with like the sensors and things.
Yeah.
Ethan, if you want to add.
To touch on that further, the camera is mounted above anything. So anything that enters the bin is going to come in, and it's the camera is going to be above that. And it right now our solution doesn't really allow for waste to get to the camera. And also it's not like, so our back is not going to be locked. It's just going to be able to be opened. So if you have a big pizza box, you can simply open up the back and deposit the box into that bin. And it'll accept it just fine.
Yeah, and I would just like to add a little to that. So right now, this is the basic solution of what we have thought, but it can obviously accommodate to changes required according to the situation and where it would be placed. And one point was about the weight sensors. So right now we've thought that it would work on weight sensors, but there was also another thing which we thought where we could have the sensing done on the top, while it could just see how much the volume has filled in terms of height. So even that could be included, and this way we can solve, like if like the issue in both parameters. So yeah.
So I want to say plastics is like my passion and getting rid of them. And it's an uphill battle. Like I have a personal situation going on right now about plastics. So I am on board with you. But I also agree with Trevor that I think there's some issues. And I would just say, one, plastic bags are a huge issue, and your machine indicated it as trash. So they go into trash, which means they blow into the ocean. And I know you know all about the plastic in the ocean. So that's one thing that was a bit concerning to me as your example. And I think the other challenging thing here is the idea of people have a recycling bin and they're like, they trust that recycling bin at their home to put stuff into as being a way that they're doing good. And so, right, that like armchair philanthropy sort of situation of like, I put all my stuff in my recycling bin and it's getting recycled, when we know that's not true, right? It's dirty, it gets sorted into the landfill ultimately. And to me, putting things into a box where people feel like, oh, it got taken care of, has some significant issues. And so like some sort of indicator that also would show like trash, 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 right? Like you think you're recycling this, but you're actually not. Because I think, based on the picture, whatever one of you put is you've put that little box that you showed from the union, it's small enough to put in there, that's going into trash. Even though everything, like most of the things in there are compostable and recyclable, but because it's contaminated, it's gonna go into the trash, right? And so like, but the user is like, hey, I just recycled that because this machine said it's recycling. So some sort of indicator of like, like you actually, like this is actually trash, I think could enhance that and put the responsibility back on the consumer, the eater, that to enhance this design.
Yeah, that's some great points. One of the main things the reason we had the trash bag kind of we had that as our example to label it as trash, because there are some things that the university doesn't take as recycling and they get put into the recycling bin. So we kind of wanted to show that like our system, as the university evolves with its recycling of what it can intake, because we've kind of talked to the Office of Campus Sustainability, and they said further in the future they want to adopt Ann Arbor's being able to take glass and stuff. All that would need to be updated is the system instead of having to fully retrain everyone. But with your point with learning, that is one of our future points that we wanted to do, either have some sort of like screen or sensor that lets the user know, once you've put this in, where did it go? So as they learn where things go in recycling and trash, and as they go places where the trash.py trash can isn't available, they know where these things go. But it allows them to learn if they want to learn and have that visual. But that is something that we've thought about having in the future. But yes, great points.
And obviously, educating users and making them more aware of the waste that they're producing and where it's going is very important and valuable. But our first and major concern and goal right now is there is, outside of what people know, there is a tangible problem with what goes where. And we aim to fix that. And if we've identified that we can take a certain percentage of all the contaminants and lost recyclables and put them where they need to go. And that by itself already has, good benefits for sustainability on campus.
I have one final question. So oftentimes with recycling, container like a yogurt container could be recyclable, but if you don't clean it out, then the recycling place will not take that. So how are you solving for that issue?
Yeah, absolutely. So we've been in talks with a lot of people that deal with especially with the Office of Campus Sustainability, about like what state, how dirty can our recyclables be, like what is what is acceptable. And so we've been given the sort of rule of thumb of like, it doesn't need to be like power washed clean, but it does need to be relatively clean. And the way that we can sort of get that information is by training the model on actual data. So right now we have a sort of a pre-made data set from a very similar problem. But once we start to launch certain bins around campus, we'll be able to constantly keep track of what gets thrown away and the data that the system receives. And because there's a separate model on the cloud side that handles all the classification, we can just go in and we can update the model, retrain it, sort of tweak the parameters a little bit to allow us to get the behavior that we want.